Today, we're going to talk about the converse of the Pythagorean theorem. Okay? This idea allows us to test whether a triangle is right, acute, or obtuse. Okay? So, we know that if this is true, if a squared plus b squared equals c squared, then we have a right triangle. But we can then actually test to see if our triangle is right or is acute or obtuse, depending on whether a squared plus b squared is bigger than c squared or smaller than c squared. If a squared plus b squared is bigger than c squared, the triangle is going to be acute, meaning all three angles in the triangle will be smaller than 90. If a squared plus b squared is smaller than c squared, meaning c squared is large, then our triangle is obtuse. Right? So, for example, okay, in this first one here, what we're going to do, we're given all three sides, we're just going to set this up as a squared plus b squared, and we want to test to see. So I'm just going to put a little question mark over the equal sign. We want to test to see if that equals c squared, or if one side of our equation is larger than the other. So the two legs of this triangle are 10 and 10 times the square root of 3. So I'm just going to put that in parentheses to signify that we're going to square every part of that. So we could put this entire side just like this into the calculator, as long as we use parentheses around the 10 times the square root of 3. Or we can do it by hand. Okay, I'll do it by hand just so that we can see this. So 10 squared is 100. Now, this piece right here, when I'm squaring something like this that has multiple terms, I need to square each term. So this is going to be 10 squared times the square root of 3 squared. So 10 squared is 100. The square root of 3 squared is 3. The square root of 3 squared is 3. Right, the square root and a square just cancels each other out. So this would be 100 times 3, or 300. Okay, but again, you can double check that in the calculator. And then 20 squared is 400. So in this case, both sides of this potential equation equal each other. So what that means is this is a right triangle. So let's do a couple more here. Right. The longest side would always have to be the hypotenuse. Yeah, would always be C. So let's try another one. How about let's do number 4. So if you look at the directions, it says first, determine whether each set of numbers can even be a triangle. Then, if it can, figure out if it's right, acute, or obtuse. So how did we do this first part? How did we determine whether the given sides could even be a triangle? Something about adding. The sum of the two smaller ones has to be greater than the third one. So in this case, to check that, the two smaller ones are 6 and 8. We want to see if that is bigger than 9. Obviously it is, right? 14 is bigger than 9. No. That would be squaring everything. So this is just to check to see whether it is even a triangle at all first. And it is. So then we can go on to the next step and see if a squared plus b squared equals c squared, is bigger than c squared, or is smaller than c squared. So, plug these values in. 6 squared plus 8 squared. And let's see how that compares to 9 squared. So 6 squared is 36. 8 squared is 64. And 9 squared is 81. So 36 plus 64 is 100. And 100 is bigger than 81. So a squared plus b squared is bigger than c squared. Therefore, this would be an acute triangle. Sure. Subtract. Oh, I think you're thinking of if we're given two sides of a triangle, how to find the range of the possible lengths of the third side.
Oh wait, never mind. Triangle could be 5
So, no, that's a good thought, but the sides we're saying are the square roots of all those. So yeah, let's try number 7 here real quick. So first we want to test to see if this is even a triangle. So, I mean, I don't know exactly what these are off the top of my head, so let's put them into the calculator and get some decimal approximations. The square root of 5 is about 2.24. The square root of 12 is 3.46. And the square root of 13 is 3.61. So, these two added together is definitely larger than the third side. So this can be a triangle. So then we can go one step further and test whether it's right, acute, or obtuse. So if I set this up as the square root of 5 squared plus the square root of 12 squared, see how that compares to the square root of 13 squared. This actually ends up being a pretty simple problem. Yeah, because the square root and the square will cancel out on every one of these numbers. So we just end up with 5 plus 12. Let's see how that compares to 13. So obviously we get 17 is bigger than 13. So a squared plus b squared is bigger than c squared. That would make this one acute. I think we've got time for one more real quick. How about number 5? Do it together. So yeah, first, we're testing to see whether these can be the sides of a triangle. We'll do 6 plus 12, and we need that to be bigger than 18. But 6 plus 12 equals 18. So this isn't even a triangle. This is a line. This is a line. So that's the end of this problem. Right? We can't test to see whether it's right, acute, or obtuse because it's not even a triangle.
And if it's not long enough, it means you don't touch.
Exactly. Yeah. That would be something like this, where we can't get up to touch.
Okay.
All right.